All right, we have an object that is launched horizontally from a cliff with a height of 30 meters above the ground, and it lands 40 meters from the bottom. I should have explained this a little bit better. Here's the situation. So the cliff, we have a height. Try that again. So we have this cliff. And what we're saying is this. We have this thing that launches, and it kind of lands like this. And what I was trying to say is that if this is x naught, this here is 40. That's what I meant to say by 40 meters from the bottom. And then this height s right here is 30. So with that in mind, what we're going to say is that this is 0, this is 40, this is unknown, and this is unknown. And in the vertical direction, we know that this is 30, u is 0, since it's falling in the vertical direction, its vertical initial speed is 0, since it only has horizontal velocity. We don't know v at the bottom. We know the acceleration is 10, and we don't know the time it takes to fall. So let's get the time at which it'll hit the ground. So we have 30, so we're going to use s equals 1/2 at squared plus u times t. And of course, u is 0. So this is going to give us 30 equals 1/2 times 10 times t squared. That's going to give us 30 equals 5t squared. We'll divide both sides by 5. And so we're going to end up getting t is the square root of 6. And when we actually simplify that out, we're getting t equals 2. I'll take it to 2 decimals for now, 2.45 seconds. All right, so that's A. Part B says the horizontal speed it was launched at. The horizontal speed it was launched at, well, we know that x equals v naught t plus x naught. So x equals v naught t plus x naught. So we have 40 equals our unknown v naught times 2.45 plus 0. So we're going to end up solving for v naught. And that's going to give us about 16.3 meters per second. Now for part C. I should have been a little clearer. I said calculate the speed with which it hits the ground. So a lot of us, and this is fine, we said v equals at plus v naught, or plus u in the vertical direction. That's v equals 10 times 2.45 plus 0, and we end up getting that the v in the vertical direction is 24.5 meters per second. And on your test, I'm going to actually change this. I'm going to say determine the vertical speed with which it hits the ground, because when I say the total speed, that's something a little bit different that we're going to talk about just a little bit later on. So that's question number 7, and we'll take a look at the last question in the very last video.